Good morning, everyone, and thank you for joining us today. In our last deep dive, we really unpacked the hybrid cloud and why a one-size-fits-all approach just doesn't work anymore. Well, today, we're taking that idea even further. We're moving beyond the traditional data center right to the very frontier of the network, the place where data is actually created. We are talking about edge computing. And let me tell you, this isn't just another tech trend. It's a massive shift, a monumental one that's being driven not by choice, but by the cold, hard limits of physics and economics.
So here's what we've got on tap. First, we're going to get a really solid handle on what the edge actually is. Then we'll dig into the powerful forces that are making this happen right now. After that, we'll look at some incredible real-world examples. And finally, we're going to bust a big myth out there, the idea that it's edge versus cloud. We'll see how they're actually becoming incredible partners.
All right, let's dive right in. First things first. Before we can really get into why the edge is such a game changer, we need to make sure we're all speaking the same language. We need to agree on what it is we're actually talking about.
So let's ask that core question. What is edge computing really? For the past decade or so, the mantra in tech has been pretty simple. Move it to the cloud. But what happens when that model starts to break down? What happens when sending all your data on a long road trip to some centralized server just isn't fast enough, or worse, is just way too expensive?
Well, that's where this comes in. And the core idea is actually a pretty simple flip, but it changes absolutely everything. Instead of moving mountains of data to the cloud to be processed, edge computing brings the processing power, the compute itself, directly to where the data is being generated.
Now, you might be thinking, okay, but we have these incredibly powerful hyperscale clouds. Why do we even need the edge? And that's a fair question. The key here is to stop thinking about them as competitors. They aren't fighting for the same job. Think of them as two highly specialized tools at opposite ends of the entire computing spectrum.
And this chart really lays it out. Look at latency. A round trip to the cloud could take hundreds of milliseconds. At the edge, we're talking sub-10 milliseconds. That's the difference between your video buffering and an autonomous car slamming on the brakes in time. Or think about bandwidth. The cloud often needs a constant, expensive fire hose of raw data. The edge, on the other hand, processes everything locally and just sends back the tiny, valuable insights. And maybe most importantly, what happens if the internet goes down? A cloud-dependent system is basically a brick. An edge device, it just keeps on working.
Okay, so this is where things can get a little fuzzy for people. You hear the terms IoT and edge thrown around together all the time, sometimes as if they mean the same thing. They absolutely do not, and getting this distinction right is crucial. Here's the best way to think about it. The billions of connected IoT devices, your smart thermostat, the sensors in a factory, the camera on a street corner, they are the world's new eyes and ears. They are creating this absolute tsunami of raw data. Edge computing? That's the local brain that sits right next to those eyes and ears, processing that data on the spot and turning that massive wave of information into an immediate, intelligent action.
This is a fantastic question, and probably one of the most important ones, because the edge isn't one specific place you can point to on a map. It's not a thing, it's a location. Really, it's a whole spectrum of locations, a continuum that stretches from the tiny device in your hand all the way back to that massive centralized cloud.
At one extreme, you have what we call the far edge. This is compute happening right on the device itself. Think about the little processor inside a smart camera. It's incredibly fast because there's no network travel time, but it's not super powerful. Then you take a step back to the near edge. This might be a small server or a gateway in the back of a retail store or at the base of a cell tower. It's got more horsepower and can aggregate data from lots of devices nearby. And then, of course, all the way at the other end, you still have the central cloud, which remains the big brain for all that heavy-duty, long-term number crunching. Okay, so now we have a really solid idea of what the edge is, which brings us to the real heart of the matter. Why is this all happening now? Why is this decentralized model suddenly becoming so absolutely critical?
And the answer really is simple. This isn't a fad. This isn't some new trend that tech companies are just pushing. The move to the edge is inevitable. It is being forced upon us by two fundamental, unchangeable sets of laws, the laws of physics and the laws of economics.
Let's start with the economics, because the numbers are just staggering. A single autonomous vehicle, just one, can generate up to 4 terabytes of data every single day. Just try to imagine the cost of uploading that to the cloud over a cellular network. It would be astronomically expensive. It's just not practical.
Or how about this one?
A single 4K security camera. We're talking over 150 gigabytes of high-definition video every day. Now multiply that by the thousands of cameras you might find in a single smart city. The cost to backhaul all of that raw video to the cloud? It's simply not financially sustainable. The business case collapses.
This whole economic reality, this problem of data getting too big to move, is captured perfectly by a powerful concept called data gravity. And it explains exactly why that old centralized cloud model is starting to hit a wall.
It's just like it sounds. The more data you generate in one place, the heavier it gets, metaphorically speaking. And that weight makes it harder and more expensive to move around. So data gravity tells us that eventually it becomes far, far more efficient to bring the compute to the data rather than trying to drag petabytes of data across the network to the compute. The edge becomes this incredibly smart filter, processing locally and only sending the most valuable little nuggets of information upstream.
And then there's physics. You simply can't argue with the speed of light. It is the universe's hard speed limit. So, a round trip for a piece of data from a factory floor in Detroit to a cloud server in Virginia and back, it takes time. It might only be milliseconds, but for a robot on an assembly line or a car trying to avoid a collision, that delay isn't a small inconvenience. It's a catastrophic failure. For these real-time systems, low latency isn't a nice-to-have feature. It's a non-negotiable requirement for safety and basic function.
So we've covered the what and the why. Now for the really fun part, let's look at how edge computing is already out there in the real world, today, making things possible that would have seemed like science fiction just a few years ago.
Okay, here's a classic smart city dilemma. You want to use cameras at intersections to understand and manage traffic flow, but you absolutely cannot and should not build a massive citywide surveillance network. So how do you get the valuable data you need without compromising the privacy of every citizen?
Well, the edge provides this perfect, really elegant solution. The smart camera, using its own onboard processor, analyzes the video feed right there at the intersection. The AI on the device identifies objects, counts them, and then immediately discards the raw video. All it ever sends to the central traffic system is a tiny, anonymous metadata packet that says something like 5 cars and 2 cyclists passed. The city gets exactly the data it needs to optimize traffic lights, and everyone's privacy is protected because the video of their faces or license plates never, ever leaves the device. It's brilliant.
We've touched on this a few times, but it really is the ultimate edge use case, so it's worth hammering this home. Why can't a self-driving car just rely on a super fast 5G connection to the cloud? I mean, 5G is fast, right?
Because of this, a self-driving car isn't just a car anymore. It's a data center on wheels. It is making thousands of critical calculations every single second. The process of identifying a child who just ran into the street, predicting their path, and applying the brakes, that whole loop has to happen in milliseconds. It simply cannot wait for a round trip to a distant server. That tiny delay, no matter how small, is the literal difference between a safe stop and a tragedy. The compute has to be on board. It is non-negotiable.
And it's definitely not just about our roads. In today's smart factories, the edge is a total game changer. It's being used for predictive maintenance, analyzing the vibrations of a machine to know it's going to fail before it breaks, saving millions in downtime. It's doing real-time quality control, with high-speed cameras spotting microscopic defects on an assembly line that a human eye could never see. And it's keeping workers safe, analyzing video feeds to spot hazards and trigger alerts before an accident can happen.
You know, all these amazing examples lead us to the final and I think most misunderstood part of this whole story. With all of this incredible power being pushed out to the edge, it's really easy to jump to the conclusion that the cloud's best days are behind it. But that couldn't be further from the truth.
This is honestly the #1 question I get about this topic. Is this some kind of either-or battle for the future of computing? Are we really about to watch the slow death of those giant hyperscale data centers that we just spent the last decade building?
The answer to that is a clear, definitive no. In fact, the rise of the edge actually makes the centralized cloud more valuable, not less. You see, the edge doesn't replace the cloud, it extends it. It acts as the cloud's distributed sensory system, reaching out into the physical world in a way the cloud never could on its own. Let's go back to that self-driving car one last time, because it illustrates this partnership perfectly. The edge, the computer inside the car itself, is responsible for the tactical, real-time doing of driving. But the cloud handles the strategic, long-term learning. It aggregates all the tricky driving scenarios from thousands of cars in the fleet, uses its immense power to learn from all that data, and then it pushes a smarter, safer, improved AI model back down to every car. So you have this beautiful loop.
The edge does, the cloud learns. One simply cannot reach its full potential without the other. I love this quote because it just sums up the whole idea perfectly. It's not a competition. It is a symbiotic, collaborative architecture. The cloud is the centralized brain, the home of deep thought and long-term learning. And the edge is the distributed nervous system, handling all the reflexes, the sensory input, and the immediate actions. You absolutely need both to create a truly intelligent system.
So to wrap it all up, what have we learned? Well, first, that the move to the edge is an inevitable consequence of physics and economics. It's about putting the compute where the data lives, to enable things like real-time response, better privacy, and true autonomy. And most critically, the future isn't edge versus cloud. It is a powerful partnership where each one makes the other stronger. Of course, for this partnership to work, you need a powerful network connecting the brain to the nervous system. And that's exactly what we'll be tackling in our next explainer. We're going to dive deep into that network fabric and explore how technologies like 5G are building the superhighway that makes this entire computing continuum possible.
And that leaves us with one final big question to think about. As we continue to embed intelligence into every device, every object around us, what previously unsolvable challenges in medicine, in logistics, in science will this powerful combination of a central brain and a global nervous system finally allow us to conquer? Thank you so much for joining us today. For more deep dive into the technology that's shaping our world, make sure you subscribe to our channel, Tech, AI, and Beyond.